morning to everyone. We are from Group 5. Today, we would like to present our assignment that entitled The Modeling of Data Using Least Square Regressions. Do you know what is least square regression? Least square regression is a widely used method to model the relationship between variables by minimizing the error between predicted and actual data values. In this presentation, we compare three different regression models, which are linear least squares, quadratic least squares, and quartic degree 4 least square. Our analysis is based on real electricity consumption data that obtained from the Department of Statistics Malaysia. We chose this topic because we as a student of engineering, we are very related to the electricity. Our objective of this study is to compare linear, quadratic, and quartic least squares regression model in terms of efficiency and predictive accuracy. This comparison is done by analyzing absolute error value and visual fitting of the plot graph. The aim is to determine which polynomial degree best represent the data trend. We choose 33 latest data from the data given, and we use two software, which is Excel and MATLAB.
For the next slide, this slide presents the data sheet for used in this analysis. The data is obtained from the Department of the Statistics Malaysia through the Open Data Portal by link at the bottom of the slide. The data contain monthly electricity consumption data in Malaysia, include a variable such as a data sector and total electricity consumption measured in kilowatts per hour. The data section explains the definition of each variable, ensuring the data is clear and well structured. The data set is suitable for numerical analysis because it is time series data, continuous is in nature, and contain more than 30 data, which is required for our project.
Now I will continue with the next slide, which is the linear least squares method. This slide shows the applications of the linear least squares method to model the relationship between X and Y data. And for the data table, which is the represent the original data set used for the calculation. The linear least squares method finds the best fit straight line by minimizing the sum of square errors between the actual data points and the predicted values. And for the result, in the linear graph shows a straight line trend that approximates the overall pattern of the data. However, some from the data points deviate from the line, indicating that the linear model may not fully capture the data behavior.
For this slide, we use the quadratic least square method to analyze the given data. We started by using the original data values as shown in the table on the slide. These data points represent the actual measured values and are used as the basis for the analysis. Next, we applied the quadratic least square method to determine the best fit equation that can represent the relationship between the variables. Using these equations, we then plotted a quadratic graph to observe the trend of electricity supply over time. From the graph, we can see that the quadratic curve is able to follow the overall pattern of the data points quite well. Compared to a straight line, the quadratic curve better represents the changes in the data, especially where the values increase and decrease gradually. This shows that the data does not follow a polylinear trend and that a quadratic model is more suitable for describing the behavior of the data.
For the next slide, a quartic degree 4 least square. This slide shows the application of the degree 4 least square method. In this method, we using a 4th degree polynomial to fit the electricity consumption data. The table display the calculate of the value x square and x cube and the x power of 4 which is used in the least square calculation. Using this value, the polynomial coefficient are determined to obtain the approximate equation. The graph comparison compares the original data consumption with the degree 4 fitted curve. From the plot, we see the quartic model capture the non-linear trend and provide a smoother approximate of the data over the time.
We continue for the comparison. 3 regression models will compare, which is the linear, quadratic, and 4th degree polynomial. Using their error values, first, the linear model has the highest error, which is the 0.0307 values, indicates the least accurate fit to the data. And second, for the quadratic model, it's reduced the error to 0.0268, showing an improved fit by capturing data curve. And the last, which is the 4th degree model, gives the lowest error, which is the 0.0254. That means it fits the data best among the three.
In conclusion, we focus on identifying which model best fits the shape of the data. We compared several polynomial models including linear, quadratic, and higher degree polynomials to see which one gives the most accurate result. From this comparison, we found that the degree 4 polynomial least square model provides the best fit. This is because its error value is the smallest when compared to the other models. A smaller error value indicates that the predicted values are closer to the actual data. We can also support this result by looking at the plotted graph shown on the slide. The degree 4 curve follows the data points more closely and matches the overall trend better than the linear and quadratic models. The linear model is too simple, while the quadratic model still does not fully capture the shape of the data. Therefore, based on both the error analysis and the visual comparison of the graph, we can conclude that the degree 4 polynomial is the most suitable model for this data set.